Okay, so today we're going to explore the physics of charge and voltage on a capacitor, and including the effects of a dielectric. But let me start just by charging this capacitor up. So I have two parallel plates here, arranged like this. And with this lead, I'm going to dump some charge on. And the way you can see that this capacitor is now charged is that the two sides of this capacitor are connected to this electroscope over here. And what you see is that that needle is telling me that there is now a voltage difference between the two plates, and that voltage difference is there because I dumped some charge on. If I take my screwdriver and discharge the capacitor just by shorting it out, I'm going to discharge the capacitor. You watch the needle. The needle goes back to zero. If you listened very, very carefully, there was a tiny spark. It's almost impossible to hear, but let's just do it again. So I'll watch the needle. I'm going to dump some charge on. And you see that when I put charge on the capacitor, there's now a voltage across the plates, and that voltage is reflected in the position of this needle, which is no longer vertical. Vertical means no voltage. Tilted over means there's some voltage between the two plates. So once again, I'll dump the voltage. I'll dump the charge through this screwdriver. Let's listen and see if we can hear the spark. You might have heard it, you might not. I could barely hear it myself. No voltage, no charge. Now we have charge on the plates. But now I'm going to play a little trick. I've put this charge on these plates. The charge is there. Nothing is changing to the charge. But now I'm going to start separating the plates by turning this. I'm going to wait till that needle is a little more steady. It's pretty steady now. So remember how much that needle is deflected. That's telling you about the voltage across the plates. And now I start increasing the separation between the plates. And as I move the plates farther and farther and farther apart, look what's happening to the needle. The needle is getting tilted much more over. That means that as I separate the plates, while keeping the charge on them the same, the voltage across the plates increases. So the capacitance is changing as I separate the plates. As I separate the plates, the capacitance is dropping, which means that for to maintain the same charge, I need a larger voltage. Now let's squeeze the plates together again. So watch the needle as I bring the plates back together, and the needle starts to come back towards the vertical. So same charge. As I vary the separation, the voltage across the plates changes. So I'm going to do this one last time, but this time instead of just touching the lead to this plate, I'm going to plug it in and leave it there. So I've charged the plate up. There's a voltage just as before. But now I'm waiting for the needle to settle down. But now when I increase the separation, I'm going to leave the battery connected, which means now as I increase the separation, this lead stays connected, and that means it's going to keep the voltage the same. So as I increase the separation, watch the needle this time. And nothing happens. The needle is staying the same. Why is that? Well, this time as I increased the separation, I kept this lead connected. That means that the battery was holding the voltage the same. And so that means that since last time, when the charge was constant, the voltage went up. Since this time the voltage is staying the same, what that means is that as I separated the plates, the charge on the plates had to go down. So as I was separating the plates, some charge was flowing back into the battery. And if I squeeze this back down again, no change to the voltage because I've left it connected to the battery. But, okay, I'll do it one last time with the lead disconnected. So disconnect this. This time, the charge will stay fixed because there's no lead connected, and so the voltage increases. And in fact, what I can do is, right there, what you see is that when I connected the lead, the charge decreased, and the voltage changed back to the voltage that the battery provides. And now when I squeeze it back down, the voltage doesn't change. So as I'm squeezing it down now, actually the charge on the plates is increasing. So there's two ways of doing this. I can either increase the separation between the plates, keeping the charge fixed, and then as I increase the separation, the voltage goes up. Or if I hold the voltage fixed, as I increase the separation, the charge on the plates goes down. Okay, last thing I'm going to do is I'm going to take this off. I've got the plates charged up. I'm going to separate them as you've seen before. Look at that. Voltage is going up, 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 up as I separate the plates. And now I'm going to see what happens if I take this piece of plexiglass and slide it between the plates. So watch the voltage as I slide this dielectric between the plates. And the voltage dropped. Why did the voltage drop? Because of the polarization that is being induced inside the plastic, inside the plexiglass. That's reducing the electric field between the plates. That's reducing the voltage. But the charge hasn't changed, as I'll show you, because when I remove this, the voltage goes back up. Voltage goes down. Voltage goes up. So this is the effect of putting a dielectric in between the parallel plates. I've kept the Q on the plates fixed the whole time, and inserting this dielectric reduces the electric field, reduces the voltage, increases the capacitance. Removing the dielectric, go back to the original situation with greater voltage, lower capacitance. Okay, so today we're going to do another experiment involving a capacitor with a dielectric in it. And my capacitor is here. And I just want to show you how it's put together first. So this is one plate of the capacitor, and it's shaped like a cup. This is the other plate of the capacitor, and it's shaped like a smaller cup. And in between them, I have this, this beaker, which is the dielectric that is the sandwich between the two metal plates. So this is a capacitor. Instead of two parallel plates, it's two cups, a bigger cup and a smaller cup with a dielectric in between. So now I want to charge this capacitor up. And I'm going to do it with this device, which is called a Wimshurst machine, named after its inventor. And what this is it's basically a lot like a Van de Graaff. I'm not going to explain in detail how it works, but it's separating charge. There's a set of brushes and points here, and basically it's sucking charge out of one plate and dumping charge on the other plate. And if what I'm saying is true, right now I have a charged up capacitor, and the way I'm going to convince you of that is I'm going to discharge it through this shorting rod, and let's just see what happens. Ah, there we go. So do you believe me it was charged? Let me try it again. So I've charged up the capacitor, and let's discharge it. There you go. So I could see the spark, I could hear the spark, and you can't, but I can actually smell the spark. That spark is actually making a little bit of ozone in the air, which I can smell. Do it a third time. So I've charged up the capacitor, a lot of charge on it right now, and I'm going to discharge it. There we go. Okay, so now what I'm going to do is I am going to take this capacitor apart when it's charged. So let me charge it up. And I'm going to start taking this capacitor apart. So very carefully, we'll take the lead off, and I'm going to pull this off. Now, you heard that spark, you saw that spark, so let's see what happens when I touch the inner piece of the capacitor. You ready? Am I ready? Okay, let me do this very carefully. Nothing happened. No sign of a spark. Nothing painful. Okay, so it must be something to do with the outer cup. So let's grab the outer cup here. Wait a minute, I'm holding the outer cup. I haven't gotten a spark. So, well, maybe even though this was no spark, this is no spark, maybe it's somehow to do with this. So let's see what happens if I do this. Listen carefully, listen for that spark. No spark. That's strange. When I had it put together, I got a spark when I connected these two. There was a charge across the capacitor, the charge on the capacitor. There was a voltage across the capacitor, got a big spark. So where's the charge? Doesn't seem to be on either of these. What about this? Could the charge be on this? So let's find out. Let's put the capacitor back together. I'll put the capacitor back together. Now it's back together, and boom. So that means that when I took this capacitor apart, essentially all the charge was on this Pyrex beaker, the sandwich between the two plates. So what's happening here is that this is a very good dielectric, and so when I put this together like this and charge it up, there is such a strong dielectric effect that most of the charge ends up on the inside and outside of the beaker, and there's very little charge remaining on the two metal plates here. But nevertheless, when I put it back together, I got the big sparks. Let's do this one more time. Make sure you believe me. So I'm going to do everything over again. Connect this like this. Charge it up. Okay, so that was a big charge. So take that off. Take this out. No spark. Take this out, no spark. And actually, whoa, I got a spark there. So there is actually charge on this. I can get a spark. I don't know if you heard it, but I certainly felt it. So there's definitely charge in here. Let's see whether I got it all. Put this back together. Put that back together. And let's see whether there's any more. There was. So I actually got a small spark through my fingers when I was touching the beaker. And with my fingers, I was discharging only the spots that I touched. But when I put this back together in the sandwich, these aluminum cups are designed to pick up all the charge off the dielectric. And that's why when I discharged it, I got a big spark. Should we do it one last time? We'll do it one last time just for fun. Here we go. I'll charge it up maybe 15 turns. Last time I did 10. It was actually 18 turns. Okay, last time. Nothing. Nothing here. All the charge is on here. Put it back together. I'll do it over here this time. And here we go. You ready? Here we go. There it is. And so that gives you a real sense of what a dielectric does inside a capacitor.